Graph a right triangle with the 2 points forming the hypotenuse. Using the sides, find the distance between the points in simplest radical form. -4, 2 and -7, 5. Click twice to draw a line. Click a segment to erase it. So here is one part, and here's another part. So first we draw those horizontal segments. And so we see this first one goes from -7 to -4, so that's 3. So we would do a squared plus b squared equals c squared for this right triangle. And it's 3 squared plus 3 squared equals c squared. 9 plus 9 equals c squared, or 18 equals c squared. So the square root of 18 is in radical form, but it's not in simplest radical form. To get it in simplest radical form, we're going to have to divide out any perfect squares. So we know that this could break down into 9 and 2. So this is going to be 3 times the square root of 2 for the hypotenuse. So down below, we put leg 1 is 3, leg 2 is 3, and then 3 square root 2 is going to be the answer for the hypotenuse. Let's try another one. Graph a right triangle. So now we got -3, 7 and 3, 3. So let's draw the legs. Okay, now we can answer the questions below. So from -3 up to +3, that leg is 6. From 3 up to 7, that leg is 4. So we need to use the Pythagorean theorem with that. A squared plus b squared equals c squared. 6 squared plus 4 squared equals c squared. 36 plus 16. 36 plus 16 is 52. So c is the square root of 52. That's divisible by 4. So that's 4 times 13. And the square root of 4 is 2. So that's 2 times the square root of 13. If we have not been given the graph, but just the points, then we're going to have to use the distance formula to calculate our distance. So 0, -1, and 3, -5, we could plug into this formula. So 0, or 3 minus 0 squared, are the x values, and -5 minus -1 are the y values. 3 minus 0 is 3, and 3 squared is 9. -5 plus 1 is -4, which when we square it is 16. 9 plus 16 is 25, so this one works out just to 5. And this next one says find the distance between the 2 points. So again, 8 minus 4 would be x minus x. -3 minus 4 would be y minus y. 8 minus 4 is 4, and 4 squared is 16. -3 minus 4 is -7, which when you square that is 49. If we calculate 16 plus 49, you get 65. And 65 does not break down any further, so let's just put square root 65. Draw a line representing the rise and a line representing the run of the line. State the slope of the line in simplest form. Click twice to plot each segment. So if we're going to start, find a point where it meets. So like right here. So it looks like if we go from here to here, from here to here, we can see that it goes 1, 2, 3, 4 to the right, and 3 up. So the rise over the run would be, it goes up 3, but to the right 4. So that means that the slope of this line is 3/4. This line has a negative slope, so find a point where it meets. Looks like this one goes maybe up to here. So for the rise over the run, it goes down 2, but to the right 4. If we reduce that, that'd be -1/2. They do say simplest form. If we're not given a graph, we have to use the slope formula, y2 minus y1 over x2 minus x1. What is the slope of the line that passes through 5, -4 and 7, -4? If we do y minus y, that's going to be -4 minus -4 over x minus x, which is 7 minus 5. In the top you get 0, in the bottom you get 2, and 0 divided by 2 is 0. So that's going to be a horizontal line. In the next one, if we apply the slope formula, it's -2 minus -1 over -6 minus -8. So -2 plus 1 is -1. -6 plus 8 is +2, so that'd be a -1/2. In the diagram below of triangle VWX, y is a midpoint and z is a midpoint, which makes this a midsegment. If the measure of angle YZW is 64 minus 2x, and the measure of angle VXZ is 92 minus 9x, what is the measure of angle VXZ? So they want to know what this angle measure is. This comes down to understanding that the midsegment is parallel to this opposite side, and if that's true, then these two angles would be corresponding and congruent. So we know that we can set those two angles equal. 64 minus 2x equals 92 minus 9x. So let's solve that. We get 7x over here if we add 9x to both sides. If we subtract 92 minus 64, you get 28. And so x equals 4. Now let's plug that back in. 92 minus 9 times 4. And you get 56. So that means that both this angle and this angle are both 56 degrees because they are parallel to each other. In the next question, it says E is the midpoint and F is the midpoint, which makes us a midsegment. EF is 6x minus 31 and BD is 64 minus 9x. And they want to know what EF is. And the relationship between these two is that 2 times EF equals BD, or EF is equal to half of BD. And you can use either one of those. I usually prefer to double than to half, but it works either way. So if I do 2 times EF, that's going to be 2 times 6x minus 31 equals 64 minus 9x. So 12x minus 62 equals 64 minus 9x. 3x, if we subtract then, oh, no, we got to add. So 21x, if we add the 9x, equals 64 plus 66 is 130. I'm sorry, 64 plus 62 is 126. If we divide that by 21, we get 6. Now that we know that x is 6, we can plug it back into the one that they want, and the one that they want is EF. And EF is 6 times 6 minus 31. So 36 minus 31 is 5. In triangle VWX, V is 74 and W is 96, which means that leaves 180 minus 74 minus 96, or 10 degrees left for angle X. So as we draw this, I would draw a small, a big, and a medium-sized angle. So 96, 74, and 10 are W, X, and V. Across from 96 is the biggest side, across from 10 is the small side, and across from V is the medium side. They want to list them from smallest to greatest according to these inequalities. So it would be WV first, XW second, and XV third, although maybe they might flip-flop those orders. So WV would be this one or this one, and then WX has to be this one, and then XV, this is the one that's true. Which of the following sets of numbers could represent the three sides of a triangle? Let's see. 10 plus 20 is not more than 32. So that would be a no. And 10 plus 21 is still not more than 32. So that's a no. And 5 plus 14 is greater than 18. So that's a yes. 8 plus 22 is not more than 32. So the one that works is this one. Remember that two sides have to always add up to more than the third side in a triangle. That's the triangle inequality.